So far, some tools we've talked about to simplify radicals are the product and quotient rules, where you can like combine multiplication or split up, same thing with division, and then breaking radicals down using perfect squares. Today we're going to talk about two more tools that you might use. The first one is distribute. So like any number, you always want to distribute anything in front of parentheses, and then combine like terms. So just like you've done with algebra stuff so far, anytime you have like terms, you want to combine them. With radicals, to be like terms, they have to have the exact same radical. And if there are variables, they still have to have the same variables with the same exponents. So what I mean by that is like the square root of 2 and square root of 2. If this would be like 3 square root of 2 and 5 square root of 2. See how these have the same radical? They both have a square root of 2. That makes them like terms. So if I were adding them, just imagine this was an x. If I had 3x plus 5x, I would get 8x. The coefficient in front adds, but the x part stays the same. Same thing with radicals. We'll add 3 plus 5 and get 8, but the root of 2 part stays as it is, just square root of 2. It doesn't combine at all. It's just I had 3 of these plus 5 of them, which gives me 8 of them. So don't try to combine those radicals, just add up the coefficient. If there was a variable as part of this, like if this one had an x and this one didn't, they would no longer be like terms. But if this one did have an x, now they are like terms. And again, all you do is add the coefficient in front. 3 of this plus 5 of this would give you 8x root of 2. Okay, so let's try a few examples of simplifying. So 2 root of 5 times square root of 6 plus 2. None of that breaks down or anything, but notice, just like with any number, if I have something in front of parentheses, it needs to be distributed to everything inside the parentheses. So 2 root of 5 needs multiplied by both of those terms. So what is 2 root of 5 times the square root of 6? Let's just write that out. 2 root of 5 times the square root of 6 and 2 root of 5 times 2. Remember, the product rule says if I'm multiplying radicals, I can just multiply them all together. This is basically 2 root of 5 times 6, which is 30. Same thing for anything outside the parentheses. We can multiply those together too. So 2 times 2 is 4 root of 5. If you want to just jump straight from here to here, that's fine. Like 2 root of 5 times 2 is 4 root of 5. Does any of this break down? Let's see. 5 doesn't, but could we help any of this escape? Like, does 30 divide by 4 or by 9 or by 16? You may want to try it. It actually doesn't. So 30 cannot break down at all. That is my final answer. Okay, let's try another one. Again, since this is directly in front of the parentheses, it will need to be distributed to both of those terms. You may want to try this one. So negative 3 times 2 is negative 6, and there was also a square root of 3 hanging on there. Plus, I'm going to not put the plus yet because this is negative. So negative 3 root of 3 times the square root of 6. The negative 3 is nothing to multiply with, but square root of 3 times square root of 6 is square root of 18. All right, so we distributed, that's good. But if you can keep breaking things down, you want to do that to fully simplify it. Square root of 3 doesn't break down, but 18 will. I could split it into 6 and 3, but that's not helpful because I can't square root 6 or 3. So instead, I'll split it into 9 and 2. The square root of 9 is 3. So now I need to combine anything outside the radical, and this was all being multiplied, so I'm going to multiply 3 times 3 and get 9 root of 2. And it was negative, and I also had this. So that's my final answer on that one. So that's how distributing works. Now let's look at a few combining like terms. Again, when you combine like terms, all you do is add the coefficients in front. 4 plus 5 is 9, root of 2. That's it. What if we had like 6 root of x minus 2 root of x plus 16 root of 5x? Again, to be like terms, they have to have the exact same radical. So these two are the same, but this one's not, because square root of 5x is not the same as square root of x. So that one's just going to have to stay as it is. These two, if I have 6 but take away 2, that leaves me with 4 root of x, plus this. Nothing else breaks down here, so we are done. Also, I know that these square root evenly, but there's no square root sign over them, so don't try to get crazy and square root those. Let's do just 2 more examples here. Let's get a little crazier. Okay, so you have to be careful and make sure your radical signs go over exactly what you mean them to, because sometimes we get a little crazy with our radicals and include stuff we didn't mean to. So, at the moment, none of these are like terms. None of them have the same radical. Also, there's nothing to distribute. But remember that toolbox. There's lots of different things you might try, and there's no one order that they might happen in. You just got to try what you can and see if it helps at all. So in this case, I might try breaking down some of these radicals. Like 50 splits into 25 and 2. And the square root of 25 is 5. 5 times 2 is 10. And the square root of x to the 6th is x cubed. Because x cubed times x cubed gives you x to the 6th. So ultimately, that leaves me with 2 times 5, which is 10, times x cubed, times square root of 2. That was a x cubed, not a 3 here, sorry. On this one, 18 breaks into 9 and 2, and square root of x squared, and negative 4x. I'm going to try not to lose anything this time. The square root of 9 is 3. The square root of x squared is x. And now I'm just going to multiply everything together here. Negative 4 times 3 is negative 12. Both of these are outside the radical now, so x times x is x squared. The only thing left under the radical was square root of 2. And this one doesn't break down at all. I'm just going to write that down. Negative x cubed root of 2. Okay, so now you'll notice that I actually have all the same radical. After all that breaking down, these are pretty similar. Square root of 2, square root of 2, square root of 2. But be careful, to be like terms, they have to be the same radical, But the same rules from the last unit still apply. They have to have the same variable with the same exponent. So this has x cubed root of 2, and this one has x cubed root of 2, but this one is x squared root of 2. It's not the same exponent, so they're not like terms. All right. Technically, this is like -1. Keep that in mind. So if I have 10 of these and take away one of them, that leaves me with 9 x cubed root of 2's. Remember, the variable and radical doesn't change, and then this is just going to have to stay by itself. That's my final answer on that one. And finally, let's do one final example. That's a big 5, not a small 5, sorry. That's a big 3. There are often multiple ways you could do this. Like, I could go ahead and break down square root of 8, but I like to distribute first whenever I can, so I'm going to distribute this to both of those terms, because I'm probably going to have to break down at the end anyway. So 5 has nothing to multiply by, so it's just 5, and 2x times 8x is 16. X times x is x squared. Plus, now I'll do 5 square root of 2x times all of this. 5 times 3 is 15, and then under the radical we've got 2 times 15, which is 30, and x times x squared, which is x cubed. And I'll just break these down a little bit. So 16, you might be tempted to split this into 4 and 4, but be careful, the square root of 16 is just 4. I know what the square root of 16 is. It's just plain old 4. So I've got 5 times 4 times the square root of x squared. The square root of x squared is just x. So 5 times 4, which is 20, times x. Well, that just worked out. It all escaped the radical there. On this one, remember 30 doesn't break down. We tried that on the previous problem, but x cubed will. I could split x cubed into square root of x squared and the square root of x, because 2, 1 makes 3. And the square root of x squared is x. So that leaves me with 15 times the square root of 30, because it hasn't been square rooted yet, times x times the square root of x. The stuff on the outside would be 15 and x, and under the radical, that would be 30 and x. So that's my final answer on that one. Just to wrap this up, here's all the rules we've talked about so far. The product and quotient rules, breaking them down as much as you can. And now you can distribute and combine like terms.